Okay, good morning class. So today we're looking at 3 problems, 2 dimensions and 3 dimensions. At this point, we're looking at the examples for exercise 4. Did we do this already? Okay, let us finish. What's happening here? PP. Yep. Yeah, place is probably in the wrong place. But this is the last example, no? Right. Let's get our marker. Okay, so we're looking at the worked example on page. Sorry? Page example. Page 128. And this is the examples for exercise 4 on page 128. Is that correct? Right. So what do you notice here? What's the difference with what we are dealing with and what we have dealt with before? You'll see that here we have something we need to prove. We have more letters here. Can you see that, people? Earlier on they asked us to work out the length of BD. But here they're asking us to prove that BD can be written as variables. Can you see that, people? As I indicated before, there won't only be numbers in which we're working with. Okay? But since you guys have mastered the other one, so this is going to become easy now. Okay? So we are told that in the figure, BCD lies in the same horizontal plane. We assume that's the ground. Okay? AB is a vertical pole, so if that's vertical, it stands 90 to the horizontal. Alright. The angle of elevation from D to A, 60 degrees. BC is X and CBD is 30 degrees. Then we are told that BDC is theta. The question says prove that DB is equal to the story here. Okay. So if you're looking at BD is actually the link between the two triangles. Not so. Alright. So what do we need? What do we need here? We can see that BD, so we must use this angle here, not so. Okay, as you can see, we've got many angles, so we're going to use which rule? Sine or cos? The sine rule. Okay, so intra-angle BDC. Okay, what can we say? That angle C is going to be 180 minus 30 plus theta. We could have said it's 150 plus minus theta, but then I must bring the 180 in again to use the reduction formula. So what I'm going to do is I'm going to keep this as 180 minus theta plus 30. Okay. So let's go with the sine rule. So we go sine of 180 minus 30 plus theta over BD is equal to sine of, now which one of the two are we going to use? Theta over x or 30 over DC? Theta over x. Okay, as you can see, there's an x involved here as well. Okay. So as you can see, I can reduce that, not so. And I'm going to cross multiply at the same time. So sine 180 minus theta takes you to the second quadrant. Sine is positive. So it's positive sine 30 plus theta times x, which is x sine 30 plus theta equals BD sine of theta. But did I get BD on its own? So I'm going to divide both sides by sine theta. Okay, so that cancels. So BD, can the thetas cancel here? Did the sines cancel? No. However, how can sine 30 plus theta be written as? Can be written as sine 30 cos theta plus cos 30 sine theta. We're going to use the compound angles here, not so? So let's go. So it's going to be x into sine 30 cos theta plus cos 30 sine theta. This is all over sine theta. Okay. So say, hang on, if I look at what we need to prove, is no sine of 30 or cos of 30. So what I'm going to use, I'm going to use the special angles there. Okay. Special angles for 30 degrees, that's going to be 1, 2, root 3. What is sine of 30? 1 over 2. What is cos of 30? Root 3 over 2. Not so? Look over that thing. So it's x into 1 over 2 cos theta plus root 3 over 2 sine theta. And this is all over sine theta. You say, hang on. I don't have a sine theta in the denominator. Not so? You see that the x is on the outside. Can you see the x on the outside here? The x on the outside. So I'm going to keep that x on the outside. What you see, the resemblance of there, we keep it like that. Okay, so it's going to give us this work in the long run. Alright. So let's go. What you also should notice at this point is that we don't have this, so we put each one over its own. Okay. So what you should see now is x into of cos theta over sine theta. You all agree with that? Plus square root 3 sine theta over sine theta. You all agree with that? So what happens now? Sines cancels, not so? Yeah, these are the 2 as well. No? So the sines cancel, so what do I have? X into root 3 over 2 plus, what is sine of a cos? Sine of a cos? Sine of a cos? 10 years. Cos over sine? 1 over 10. So that's going to be 1 over, the 2 is at the bottom, 2 tan theta. So hang on, what do you notice here? Half is a common factor here. Can you see that? So this is going to be a half x, or x over 2 into the square root of 3 plus 1 over 10 of x. Okay? You guys can just refer back to the video later. So let's just get the last question in. For homework, I would like you guys to conclude the next exercise, okay, which is exercise 4. Then the question says, we must show that the area of triangle, I need to go up. The area of triangle BDC is given as that thing. So as you can see, some resemblance of our previous answer in here, not so? So, which means to say, if I want to calculate the area of this triangle, I must use BD. Can you see that? And which other length do I have? I have this. I don't have BDC. Can you see that, people? So, for us to use the sine rule, or the area, sorry, I need 2 lengths and included angle, which I do have. So the area is going to be of BD times BC sine of DBC, which is simply of BD is going to be x over 2, remember this is BD, into the square root of 3 plus 1 over tan of theta, times BC, which is x, sine of 30 degrees. But we know that sine of 30 is what? 1 over 2, not so? So it's going to be 1 over 2 times x over 2 times the root 3 plus 1 over tan theta times x times half. What's a half times half? Quarter times half is 1 over 8. Okay? Then x times x is x squared, which looks like a thing. Root 3 plus 1 over tan theta. And then we have proven that the area can be written as that. Do you guys understand? Alright, there are 7 sums in that exercise. Please complete the first 4 for tomorrow. People enjoy the rest of your day. Good morning, class.